towards the end, so we recommend to reach out to us, to either Siva or myself, if you want to discuss in further detail. So just quickly, speaking of we, who is on the phone? So first of all, Siva.
Yeah,
introduce
hello,
yourself.
hello everyone. This is Siva Pariti, working as Senior Technical Marketing Officer located in UK now for Bluebeam.
Right, and I am Tamara Wolf, Senior Project Officer, also working for Bluebeam. I'm responsible for everything related to projects, program development, and then the successful implementation of such. Together we work for Bluebeam STS. So looking at the crowd who signed up and who I'm seeing here, you actually know who we are. And then there are a few persons I am not familiar with. So just quickly about the company, we are working for Sustainable Textile Solutions. That's a brand of Bluebeam Limited. So if you hear both names, don't get confused. We have a global team of consultants and subject matter experts, and we are on a mission to contribute to better world and life qualities by providing solutions which reduce the adverse effects of the fashion industry on the planet and climate. And we are based in the typical production countries from where we work in around 40 countries, and we are headquartered in the UK. So the objective of our webinar today, we want to introduce you to two concepts. The one is chemical selection based on PTE. PTE is the potential to emit. And the second one is process selection by emission calculations. So before we go now into that technical part, allow me to set the scenes for the technical discussion. So we all know, and we are all part of that industry for long, the fashion industry has come a very long way, right? Initially, we were just providing clothes, and nowadays it's a real style statement and allows people to express opinions. At the same time, all of us who are on this webinar, we know it's a super resource-intensive sector contributing to global pollution. So while I'm showing you here a range of KPIs, there's one which I actually feel very alert about. So if we imagine all those KPIs are as predicted, so given the size of the industry, the growth, the consumption patterns, then research shows that the industry is set to use 25% of our carbon budget in case we are warming by 2 degrees by 2050. I feel that's alarming. And I'm sure you feel the same. That's why we are on the webinar. So also, I'm sure most of you know the planetary boundaries concept, but just giving you a quick intro. In 2009, Johan Rockström led a group of 28 internationally renowned scientists, and they looked into 9 planetary boundaries. And those regulate the stability and resilience of the Earth system, and they set like quantitative measures to it. And within those measures, we can develop, grow, and thrive for generations to come. However, the moment we cross any of those boundaries, we increase the risk of generating large-scale or irreversible environmental changes. And I guess we're seeing that in the media almost every day, that we have some areas where it's become very, very critical for us. So for the textile production, we are knowing we are resource intensive. There's like a range of contributions, right? Climate change, biodiversity loss, land use change, freshwater use, NNP flows, and chemical pollution, and just naming a few. And already today, our industry contributes to 10% of the global emissions. So looking at the brand perspective, and looking at those of you who have been reporting your Scope 3 emissions, we found that typically most of you have 80 to 90% of your emissions in Scope 3. So whoever is not familiar with the Scope 1, 2, and 3 concept of emissions, I've taken that just to remind that the emissions are not directly happening normally in your headquarters, but down in your supply chain where production happens. Of course, like the 80 or 90% are a little bit of a moving thing, depending a little bit on your business model. But so why am I speaking about this? Because wet processing happens in scope 3. And since we speak about chemicals, we also speak about wet processing and about scope 3. And the question is there a role for chemicals in reducing emissions from wet processing? And for a while, we are already associated with the Apparel Impact Institute, and Kurt Kipke, who is a vice president there, actually has a message for us. So let us listen to what Kurt has to say.
Hi, my name is Kurt Kipke, and I head up programs at Apparel Impact Institute. At Apparel Impact Institute, our objective is to identify, fund, scale, and measure quantified impact programs with a focus on energy, water, and chemicals. For years, my team has implemented and developed programs aimed at energy and water efficiency. And just over the last couple of years, in partnership with STS and strategic partners at AII, we've begun expanding some of those program capabilities into chemistry and wastewater best practices that we feel align in the same approaches as our energy and water programs. What we've learned and what we've identified is that very similar approaches, characteristics, and management styles as we begin to work with our brand partners and production suppliers within the industry are very replicable and applicable. And therefore, we see a very large and significant opportunity for bringing programming approaches and tools and resources together to provide more holistic programming that enables gateways for chemistry, wastewater, energy, and water programs.
I am hearing you can neither hear the video nor the sound. Is that true for everybody? Or can you just push me a message in the chat function? I can see and hear. Okay, so if you can see and hear, I continue. So it's not for everybody. And I continue the message. Thank you for the feedback.
To work hand in hand in a way that drives overall improved environmental practices. In particular, for organizations who are setting and anticipating the achievement of science-based targets surrounding climate, there's incredibly close synergies between work that the industry as a whole can be doing to manage resources across these focus areas of impact. I'm very happy to be here today to share my insights with you, and I look forward to future engagement with the STS team and the work that all of you will take forward. Thank you.
So thank you, Kurt. So apologies for those that couldn't hear, and good for those who could hear. I'm very much wondering why some can and why some cannot hear, but let us just continue. So basically, we have been working with the Apparel Impact Institute, and whenever it was about program development, we had very interesting dialogues, because what was really driving us all the time is what makes a program work and what doesn't. And normally, and I think that's very, very normal. We think about the engineering side of things, right? We believe we go into the factory, change something, it's going to fit, it will work, and things will change, and everything is good. That's probably because many of us are engineers, or we expect engineers to go into the factory and help them improve. However, there is a very important aspect to change, and we are speaking about a lot of change because we ask people to do things differently, and Siva will tell you how to do those things differently. But the first thing is we need to remember that we are speaking to people, and humans are creatures of habit. That means it takes several days to 8 months to form a new habit. Saying basically that if you just go in once, we will not be able to change their way of working, and that's where we have to get now, right? So we are strongly recommending choosing a programmatic approach to emission reduction rather than several one-off activities, right? A typical thing is You have a budget for a year, you're thinking for a year, you're going in with one activity, you're going out, and then you're planning your budget for the next year. And then, but what we recommend is that you continuously find a way to work with the factories and have a relationship on which you build. Some of you I know do that, others I know do not yet do that. But if you want to have change, you want to create habits, you have to remind people all the time. So then also mills operate under tremendous pressures, and they vary from unit to unit. So cost, production, quality, sustainability, expertise, they are all on different levels. So normally we go into a program and say, look, this is the program, it's a one-size-fits-all approach. But that is not the case. You know that. You have factories who are really, really good, and you have factories who really need a lot of support. But so far, we have always come with the same programs. And I don't want to say it's a waste of money, but I think we could create more impact by finding ways where we engage beyond the one-size-fits-all. Then data collection, in particular for energy and water. We have HIC, and we are very happy about HIC data. We are also not yet sure how reliable that data is. And we have to build the capability with the factories that they can collect the data consistently and correctly. Because how will you otherwise be able to really demonstrate your reductions? And then there's another point. It's not easy always to find the experts who deliver. Some of you have really good own environmental teams. Others don't and work a lot with externals. But then if you go into the factory and someone comes, I mean, it depends on so many things: experience, personality, the fit, the relationship. And if there's no relationship, then it will be hard. But for the relationship, you need the factory's respect also. So you need experts with a lot of experience. So that is just something that we realized, that if you really want to build the trust and want to change, build the relationship with experts who know what they are doing and who've done that before, or if they have not done it before, because it's an innovative program, who have the capability, and run a pilot, learn before you scale it up. So that's what Kurt and I both discussed a lot, and we continue that discussion, how we can best do that. I just want to emphasize that from my perspective as a program designer or developer. Okay, but now comes the part why you're mostly here in this webinar. So let's dive deeper into the technical side. Most important resources in wet processing: raw materials, water, energy, chemicals. I think that's clear, nothing to discuss here. And just a short reminder, efficient utilization of resources is key for making any process sustainable. And chemicals play an integral role in wet processing. So now I have Siver, who will speak what is his thought and how we can connect the chemicals and the energy work, and actually with a different chemical selection impact the energy savings and go beyond only, I don't want to say only because it's already a big step, utility. So Siver, it's you now.
Thanks, Tamara. So the next slide, please. Yeah, so we all are actually looking at creating the impact, and resource efficiency is a major part because we are not expected to waste any of our resources. First thing is to ensure that our resources are utilized properly and get 100% out of it, the efficiency part. So while doing that, we all know that there are various parameters, and raw material selection could be the starting point of the parameter, and dye selection, auxiliary selection, or chemical selection. process selection. These are the three most important parts which we will look into today's webinar right now. And there are, of course, various other factors like machine selection, reduce use of resources, and get out of the same output, or reuse of the resources. I'm not even talking about the water or ZLD kind of thing. These are all various aspects, but we will focus on chemical selection, dyestuff selection, and process selection as the major part, how they are interrelated into our current topic of resource efficiency. So we are only focusing right now on energy. So I'm not talking about water saving, though you can see that water saving measures, energy saving measures, there are interconnectivities, like for example, RFT. So right first time process. So when you are doing anything at right first time, probably you are going to achieve that in the lowest time possible, and you don't increase your time of production, which has a direct impact on various aspects, including profitability, including the productivity, the time, the number of people. Some mills will say, oh, you are increasing my productivity. That's good. I will produce more. Some people will say, I don't want to produce more. I want to cut my number of people. I want to cut my time of production. I want to keep my production same, but I don't want to work 8 hours. I am fine with 5 hours. These are various things will happen at the mill level. So we need to understand what mill wants and accordingly devise the methodologies for them. So for energy, we are knowing, so we wanted to look at the role of chemicals to get the energy saving of a chemical process selection. How do you reduce the energy reduction? Of course, including the ETP loading, for example, because there are also large amount of energy which is being spent in the treatment. So we are not just looking at the process time alone or process energy efficiency at an overall facility level, but we need to also look into the granularity of how a chemical is impacting the process, not just at the production of the process, but also at the end of pipeline, probably at the wastewater treatment plant, etc., so that you will know exactly the contribution of every chemical into a recipe, into a process at every stage. Yeah. So next slide, please. So now let's look at the connecting process, which is the starting point of all our system is CIL. So this is basically chemical inventory. So how do you connect the dots of the chemical inventory into managing or reducing the emissions? So till now we have seen how do you select the right chemical for ensuring my chemical management system or ensuring my RSLs or MRSLs, but now going beyond that, that's what we are looking at. Yeah. So first and foremost, from a proper chemical inventory, we should be able to know from the section 2, which is not given there, but section 2 is of course, and section 3 information, which is the composition information, and section 9 information. Basically, how do you use the section 9 information is the vapor pressures. When it comes to emissions, we need to also look at the possibility of what is the vapor pressure of a chemical, and what is the flash point, what is the melting point, what is the boiling point, these kind of informations which we should be looking at. And in section 10, there is a information which is hidden, that what are the emitted hazardous chemicals or hazardous gases which are emitted after combustion. So after reaction and combustion, you will also know some things. There's a good safety data sheet will tell you the emission is SOx. Emission could be carbon dioxide or carbon monoxide, could be nitrogen oxides. They will give there. And that is the place the information is somewhere there, which we are not using it effectively. So based on the section 3, 9, and 10, we know what are the potential emitting gases which are contributing to the emissions. It could be primary pollutants, it could be secondary pollutants. Now, there are two things which we will be looking at when the emissions are coming in as a potential gases. One is, of course, the utility part, that is combustion of these fuels. And these are coming and these are very well established right now. Everything is perfectly going on. Even the HIG has a very nice way of depicting and calculating the information. And when it comes to the combustion process of the fuels, we know that SOx, NOx, carbon monoxide, carbon dioxide, particulate matter and GHG emissions, these are all the ones which we are looking at and capturing them at the facility level. Now, what comes to the process level? Now, in the process, we also, right now, fugitive emissions are not in the process, but we need to also look at the potential fugitive emissions, also the VOCs, that is volatile organic chemicals, and compounds, and HAPs, that are hazardous pollutants, can also be looked at, because they are that information we need to evaluate and also calculate the PTE. What is PTE? That is potential to emit. Now, when the information is not fully understood, I would say that you take it 100% as the total chemical is getting emitted directly. So this is something which we need to look into. And how do you relate from the CAL to the process of calculating or estimating the PTE or the emissions is what we need to look into the next slide. So here we need to look at the possible emissions. When I say calculate or estimate, there are various ways of doing things. In the US EPA methodology, there are four possibilities given. One is test data, which is very simple to tell me, oh, you do testing and you estimate it. Very nice, fantastic, but it is very costly. I don't think that it will be really possible for a normal facility to get into this data from the testing, because it is not that easy. Emissions calculations are not that simple, and of course it is also very costly matter. However, that is going to give you the accurate information. So you just know what is the VOC component. Let us say it could be xylene, it could be toluene, it could be formaldehyde, whatever is the VOC component which you are looking at, and then so let it be measured by testing, by absorption technologies. There are many other air emission testing technologies, techniques available that can be done and estimate, calculate. The second is material balance approach. This is used usually when majority of the output is released to the atmosphere. For example, when you are doing coating, coating is one of the important process where you have large amount of VOCs generated. You can say lamination, coating, these kind of information, like solvents are used, or degreasing process. These are the processes where you are using high amount of solvents, and there is a possibility that these solvents go into atmosphere in a big way. In those cases, we know we need to approach in a different way through material balance approach. How much is the input, how much is the output, and what is lost. So this is a major estimate which you can always look into. And of course, most of the units may have this possibility when you are doing a printing, or when you are doing screen printing, could be also transfer printing, could be coating, could be lamination, could be in footwear industry, you are gluing. These kind of possibilities you will get into for doing this material balance approach. The source specific models, these are basically models which are developed for a specific process. For example, seamless application of the swimwear. You are doing stitching, stitchless application, or this kind of application. There are models available for a particular process, and this is not relevant to almost all applications. There are very few data available on this source specific models. The last is emission factor. This is a very common one, I would say, and the best and practical means to estimate it. I will not say it is very accurate, but it is a very good estimate to check the fugitive emissions. Data can be obtained from either the chemical suppliers or from the safety data sheet. I would give you some examples of how do you do that when I am talking an example of a printing unit. Yeah, next slide, please. So I'm taking an example of a printing unit. For example, I'm taking 4 different chemicals which is ink itself, printing ink, which is being used. There is a cleaning chemical, cleaning solvent. There is a blanket washing solvent. There is a base solution where basically you are applying for the fixing or possibilities. Now, there are two things which we are looking at. One is a VOC, that is volatile organic compound, and then the hazardous potential chemical. So there are two things which is could be all VOCs, could be HAPs as well. There are some VOCs which are not HAPs. That's why HAP is probably regulated. You can say some of them you can see that in the MRSL, some of them have in their own RSLs, and some are regulated at the government level. The US EPA HAPs are having 188 chemicals. So you need to see whether from the safety data sheet you will be easily able to identify from the CAS number given in the safety data sheet in section 3 whether there is any HAP or VOC chemical. Now that can be identified. Now look at the safety data sheet composition. Sometimes you don't get 10%. Sometimes you don't get 33%, like that. They will give you a range 5 to 10, 3 to 4, like that. So if that is the case, you take the highest value. Yeah, the maximum potential. That is what we are looking at as the emission potential. Now, taking the example from the CIL and safety data sheet information, for the ink, I know how much I am using per day, per process, per year, whatever. You can just take usage on a year basis or per process or per day process or for the particular production also you can evaluate, and then look at how much it is present in the formulation. I know I am using 1600 kgs of this particular ink. However, the VOC content of that particular chemical which is in making an important part is only 10% by weight, which means I am generating 1600 kg per year the VOC which is emitted from that particular ink. Now, because I'm taking an example that this VOC is not in the hazardous list, therefore it is 0. It is not added, carried forward as the HAP content as well. Now, but in the cleaning solvent, when the safety data sheet is taking, there is xylene involved. I did not show you. I don't want to make a very complex thing to show safety data sheets and explain. But I'm just giving you an example that in a cleaning solvent, there is xylene present and the xylene concentration is 6.2 gram per liter. So we know how many liters we are using. So therefore, we calculate the total emission of the chemical of VOC content as well as HAP. Now carry forward to the HAP as well. In the same way, for blanket wash solvent, we know how much is a percentage or ppm or concentration present of a particular chemical. For example, here xylene taken, and what is your total use, calculate the content, and then see carry forward. Like that, you can continue to add these values from the safety data sheet information. Remember, there are many more chemicals when you are looking at which can be HAPs or can be on VOCs also. And we need to calculate, estimate these data coming from the CIL.
And Siva, can you do me a favor, please?
Yeah.
Can you explain the difference between VOC and HAP and what HAP is?
So VOC is a volatile organic chemical, anything which has a lower boiling point and having a higher vapor pressure, which can go. That means the solvent, if you are taking a solvent like the simple example I can take is your nail polish remover. So nail polish remover you open, and by the time you want to apply, there is almost half a solvent is gone. So you don't think twice, you just have to apply faster so that you will use more chemical to you for the application rather than losing the chemical into the atmosphere. Why it is giving is because it is volatile. So it has a tendency to move to the air rather than be in its own state of liquid. So that is VOC. Not all VOC chemicals are considered as hazardous. Now, HAPs are those chemicals which are having hazardous potential. So those are listed in any MRSLs or RSLs or SVHCs kind of thing. These are regulated for some in some countries. In the US APA, they have 188 chemicals which are listed as HAPs. So it could be common. They may be not common. Sometimes you are only generating VOCs, volatile emissions, but they are not hazardous. So that is the difference between HAP and VOC. So sometimes you will have common, like xylene. It is both. It will be both in HAP as well as in the VOC content also. So that is why they are given xylenes. Ethylene glycol, by the way, is one of the common chemical which we are using in almost 60% of our chemical formulations, and very few brands have ethylene glycol in their radar of reviewing. But remember, if ethylene glycol is coming into the radar, most of the formulations need to change. And ethylene glycol is the most cheapest, and you will also have what do you call, most of the formulations which right now you are having, including for printing inks and liquid formulations, will have an impact when you have ethylene glycol coming into picture, and it has an impact definitely. Slowly things are going to change in the next 5 years. I think things will change in the formulation of all these chemicals because of this ethylene glycol probably. Of course, there are many glycols which are coming in and under the radar. Now, looking at the chemicals which are actually having the potential to VOC or HAP, now, and you also have an estimation possibility. I want you to look into use this information to optimize the recipe, which can actually reduce your potential to emit. Because every process, every production process is having some chemical in it, and it's following a process. It's following some time, temperature, pressure, etc. They are doing it. Now, calculate the potential emission from each process and see which one is a better process for us to follow. That's what I wanted to introduce. So the methodology is taking an example of polyester cotton blend, which is a very easy to understand and easy to correlate as well. We have a polyester cotton blend when people usually use the dyeing. All the processes, I'm just going to keep everything same, the machine same, fuel, the steam, pressure, all the processes exactly all the same. Standard process, usually people will follow alkali and hydrose, which is sodium hydrogen sulfide, Na2H2O4, which is used as a reducing agent, which can give you emission of SOx, of course, and modified process will be with acid reducing clearing agent. So these are the two things which I don't want to name any particular chemical manufacturer name, but this is something which you are following. Now, how do that impact the process and emissions? Now, the red one is the normal process. This is a typical time temperature curve, which you will see. And the green one is an optimized process. Absolutely, you have a time reduction from this. When you reduce time, of course, you are also reducing the steam consumption. You are also reducing your amount of water consumption. And you will have a little bit of productivity increase and all that. I'm not going into that detail. I am only looking at what is the GHG emission for both processes based on the only utilities. I'm not even considering the SOx reduction or NOx reduction, etc. I am only covering the process of combustion, that is utility process, taking the same utilities of a particular process mill. Now, what is the saving is 0.78 kg carbon dioxide only by this. I'm not talking about by reducing agent change. We have reduced SOx emission, that is fugitive or stack. We don't have to really look in because it could be fugitive right now. So those are not taken. Only the known things which are by fuel consumption, we are taking that, and how much we are able to reduce if you are looking at a particular scale of this process. Imagining 125 grams of a garment, and we are talking about maybe 1 million garments, then what is the total carbon dioxide emission which we have reduced, equivalent is 97.5, which means that you have taken 1734 economy class flights from London to Paris. So that's the correlation which you are looking at. But that means that process efficiency and process optimization has a definite correlation in emission reductions, not just by looking at the utilities alone. But that's something which we need to also look into. That's why process optimization is an important part. But that's not all. The next slide, please. What we need to also look into is one step ahead. This is one of the example I have just taken the internal data of a particular mill. I have also given the name of the mill, Birla Century in India, wherein we are going one step further. We should know that mill is now looking at every single article. The actual rows and columns are many more. I've just reduced them, only presenting you some of the data here. What is the data telling you is the process. Because if I want to make a shirt, I can take many possibilities, and some of the mills have various possibilities to achieve it. So what are the things? This can be in a continuous mode. You can do a yarn dyeing, you can do a fiber dyeing and spin the yarn, or you can do a continuous dyeing. In the continuous dyeing also, you can do cold pad batch, you can do dry pad steam, you can do e-control. So a particular process, a mill is having various possibilities to achieve the same article. They should evaluate which is the process which I should be following and which is the most efficient process. So, for example, keeping the substrate same, they are able to calculate for a bulk process, not a small process. For a bulk process, the total time, total steam, total fuel, total gas, natural gas which is generated, and total coal consumption for that particular, or steam consumption for that particular process, and then calculate the total water, of course, definitely, but that is not our current webinar's topic, but the total GHG emission for each and every process, even though the article is could be same, but achieving that by different. And there are also different chemicals which are added, different auxiliaries which are added. So dye stuffs, auxiliaries, recipes, and the process, all of them putting together, there are different GHGs were evaluated, and then finally this mill will select those which are having the lowest impact to water and GHG to get that particular thing. So this should be done in the development stage. And once the development stage is done and the mill is getting the bulk order, they would only use that optimized process for getting this entire production, so that they know that in producing this, they are already achieving the least amount of emissions for the process. So this is how I think in the future people need to follow, not just looking at, we know that every mill is evaluating their emissions on an annual basis or a biannual basis at a facility level by using total fuels which they are getting in. That is in general, in total. How do you reduce it? The reduction is only possible if you are knowing which is the process which is actually getting me the lowest impact. And that is when you will follow, then you will be able to do the data from these things. Yeah.
So Siva, I'm having an echo, and I don't know why, but I have a question from Alex. He asks if it's possible to find AHPs or VOCs from all the SDS. I think I know the answer already, unfortunately.
Yeah, VOCs are difficult, Alex. VOCs are not that easy to identify, but you need to have a correlation with Section 9 information. Most of the Section 9 information should be given. At least you need to evaluate in our, I think in our academy, definitely there is one section where we are covering how to identify the VOCs from the safety data sheet, and the information is from the vapor pressure usually. So you need to go a little deeper into the information given, the boiling point, the vapor pressure, flash point, these data. So you need to look into and correlate whether there is any VOC content in the air atmosphere. But about HAPs, definitely CAS numbers should be reviewed, and HAPs definitely can be looked at, because that is that's at the CAS number level. So from section 3, you can definitely get HAPs. For VOCs, you need to do a little bit more deep studies. Not easy.
But Siva, then I have a question. So we are also doing a lot of courses in chemical management. And one of the topics we continue to teach factories is SDS sheets, how to get complete SDS sheets and how to use them for the chemical inventory and how to get the chemical inventory right.
Right, yeah.
So I assume someone like Bila needs to have all of that information available to get such an overview.
It took 2 years for them to start to now to come to this level of data management, because it's not easy. Because you remember how many times I've been telling that CAL is the most key heart of it, and how do you get that information and transform that information into the process efficiency. So that link you will see from this here.
Right. But then that means we all have to go back, like really building the capacity again with the factories, because I think, so we have a module on the, we have a Blue One Academy with e-learning modules, right? So most of you who know us know that my background is psychology and not technical stuff. So I did that module, and I must say I find it very complicated. So I think I should have a very different qualification than what I have. But what do you think about building the capacity and the knowledge in the factory with the right people, and how quickly can we achieve this? Because you're showing us something very innovative, or a very structured approach to it, let me put it like this, where people need to collect all the data in order to make an informed decision. If I then look at other points, we cannot even, like in some factories, we are still at a point where we don't get the CIL, where people cannot yet calculate emissions correctly. So what do you believe is needed? And by the way, guys, we have not prepared that question, so let us see what Siva answers.
So let me explain you this. This is this has been in a transformation process. Industry is transforming continuously for sure, and this CAL preparation, I think, for getting the information about health and safety, about the managing the chemical in the storage areas and all, I think probably we have moved a long way. But there are some informations which are missing in the CIL, in the SDS. The CIL also is because there is information missing in the SDS, which means that they need to engage with the supplier, and they need to also talk to the supplier and ask them that I need this information. And I am also involved in some of these dialogues, that most of the mills say that when I am asking, they are not telling, can you come and then talk to our suppliers, etc. And I have been in that role as well. And what I understand is, if you explain the chemical supplier in a nice way, why you need it, and when you need it, probably they will be able to give you, or you have to change, because without that we will not be achieving this kind of requirement or management systems in place. Otherwise, just creating CIL for the sake of because my brand is asking is of no use. Brand is asking for a reason, and that reason is not being achieved. I think we are not doing any great help for anyone, and mills need some more time for making them to come to this level. That first we have told, okay, you do it because we need safety, we need health and safety, we need this, and then it is for your own health and for your own good thing. Now when you need to tell them that if you don't do it you are losing money, probably they will also understand it, and then they will do it, but it requires some more hand holding.
Okay, because Alex has just asked if chemical suppliers are willing to share those data, like the HAPs and VOCs. So I think you answered that, right? And
yeah.
then there
Chemical
was
manufacturers will have to share the vapor pressure data of the chemicals in the section 9. So section 9 information I have seen many times not determined. Yeah, I have seen that. And that is where most of the mills don't go back to the chemical supplier and said, give me this data. They don't go back. They only go back, oh, you did not give me the 100% formulation in section 3. So once the chemical supplier is asked to give me the data of vapor pressure, give me the data of solubility, give me the data of pH and vapor boiling point, melting points, don't tell me that not determined, not available, etc. information, probably we will change, because that is an obligation on the chemical manufacturer to give that information, because that is not secret. It's a physical property.
Right, and then Alex speaks about how brands can support, right, disclosure, and maybe that's also a very interesting point to discuss, and also to think about, because I mean I worked at brands side, and different brands have different approaches, right? How they manage their suppliers. So let's say for some, sustainability is nice to have. If you don't achieve it, it's okayish, right? And then there are other brands who really include the environmental targets in supplier scoring, or even link it to production. And the question, I believe, is, I mean, of course, there's policy, and we all want politics to drive this, right? Or we want the factories to just really understand it. But it has not worked so well in the past. So sometimes I think the brands, when they are having strong opinions and strong pressure, I think that's a very good way to drive things forward. But you cannot change the world, and I do understand the side you are in from a factory side, because you cannot like lose all your production units because you set the standards too high from a sustainability or environmental perspective.
I feel, Tamara, I think one example I would give, I remember in Taiwan, when the data schema process was initial ZDHC gateway process, data schema was happening at that time, many mills were not having a proper safety data sheet. And that is when I think the brands and safe chemical suppliers brought in all their brands and their mills have brought all their chemical suppliers into one place and started engaging, not as dictating, but engaging, that you are our supply chain partners, without you we cannot work, we need this importance, you need to develop further to increase our transparency, data management and all. And then it worked well, actually. Now look at, in those days, TNT, J&J, these are the biggest supply chain partners of Taiwanese mills. And today their safety data sheets are much better than what it was in 4 years before. And they involved and engaged in their own R&D team and 3 PhDs, etc. They have and they changed everything. Safety data sheets change in 6 months' time. And this is the process in which I think a brand also has a role to play. Mills also definitely, and I would say policy, because a mill don't create a policy to ensure that what is the right to get as a right to know information in a chemical. If they don't get it in right and they don't communicate it, I think that's where probably, because people are looking at the price cheap, and that is the only factor, then it will not work, and it's a long way to go.
Just looking at the time, but Joyce has brought up a very interesting point, and since I'm not sure everybody's reading the chat, so Joyce was asking, like, how much could emissions be reduced basically in a factory? And you have also given an answer, so maybe you want to elaborate a little bit what you think, and also how early we are in these discussions. But yeah. I think they're in particular important for those factories who have done everything when it comes to changing light bulb. No, that was energy. Sorry, in changing other things for emissions. Yeah. And maybe you wanna dive into that.
So I think it also, there is a disclaimer I have to actually tell you, that not every facility is possible to have one number, but definitely in a mill like Birla Century, which you have an exhaust dyeing process, a continuous dyeing process, you have a possibility to choose the right process, because usually, I'm not telling that mills are doing wrong. I'm not telling that. Mills will choose a particular process for some reason. Availability, price, efficiency, some small changes here and there, and probably a particular process is very efficient, but they don't follow that process because if you are not, if you're not vigilant in the night shift, you will not get the same shade. So that's also a possibility that what do you call as robustness? If you are not vigilant, you will not get the right shade. So therefore, all these aspects will come into picture. However, by looking at only process efficiency, I am sure about 10% definitely reduction. That is also seen in this particular Excel table. We have seen up to 10 to 13 to 12%, 15% of variation between the processes, and then that is one. Number two, we are not changing the chemical. We are not substituting a chemical to look for more sustainable process. We are only changing the recipe here and there by looking at the steam pressure, the pump speed, etc. These are some things which are operational. Then comes to change of chemistry. Change of chemistry definitely has an impact. Then comes to change of utilities. Change of utilities, for example, a renewable source of energy or coal has changed to some biogas, then your emission will change. So there are three possibilities of the emissions to come into picture in a facility. The easiest one is a fuel. That's everyone will understand in numbers. The difficult one is the process and operation, which we need little bit more focus on. And this thing, it is new. Definitely, as I told, 2 years before we started this process, and now I have something to show. And definitely there is a possibility.
Right, and also I think from the pilot program we are doing with Clean by Design on chemicals work, I think what I have been seeing is that, and what we have totally underestimated, is the amount of hand-holding that factories need when you like really need the chemicals data, and to get the data right in order to do whatever you want to do, right? I mean, there we optimized recipes also for different reasons eventually. But just collecting the right information was a very, very lengthy process that required a lot of education.
Yeah, that is true. And for ARA, I think in this, what I am showing you is not the chemicals, but the process. So yeah, you see, but by taking one process than the other in row number 10 to 11, if you see, there's a difference. And you can then look into those different processes and say that this process is much better than the other process. So idea is that to get to one article, look at all the possible processes, identify which is the most optimized one, and then take that forward and do it in a bulk production. That is the most aspect. Right now, what we are doing is for color, we are doing that assessment in the lab. We don't do this assessment of energy and emission factor. We probably know for water for sure, but energy and emission factor we are not looking at. And for that, I would say that start doing it now, because emissions are not easy. Emission controls and reductions are not easy after a point. After you've taken everything to do with renewables, I think you have nowhere else to go. And that's where you need to look into the role of chemicals into this picture.
And Siva, one last question. I think for many programs, we have always trained the compliance or environmental manager. Don't laugh, but I have a slight feeling, who do we have to address in the wet processing units if we talk about topics like emission reduction and recipe optimization? Because I think if we now start train the compliance manager, that is like you would train me. Yeah. Again, guys, I have a lot of knowledge compared to other psychologists on textiles, but probably still not enough to implement what Siva is just telling us here. So Siva, who would be like, who have you been talking to in the factories for example, here with Birla, when you looked into that?
In this particular example, the advantage for me is that people in the development, they have a development team and not the lab team or production team. So both of them, if you talk, we will lose more time. Of course, that is not possible that they will understand. We will lose more time because their focus are different. But the development team has a role to play. bigger role to play because they are having enough time and their job is to actually develop a process which is more sustainable and more useful for them. So having done all the exercise of the CAL creation by the EHS manager, now shift your focus to the development team. And if the development team is not there, pick your person from either lab or from production. But production manager will not be the right person. He understands it, but he will not have time. So we need to gather our own team. We created this team in Birla. It was not there earlier. So we created one from the lab, two from the production, so that they understand the moment I said, don't do this, why are you taking this process? This process is not needed. Change the process. Then they need to understand the recipes and processes and in their own factory. And then we need lot of steam meters, flow meters, and also energy meters for every single step. So it's not a simple stage to start with, of course, but definitely this is the future. I think I think we are ahead of time for sure, but this is the need which is coming up.
Okay, so if I summarize it, if you wanted to do a pilot, select a factory that has an R&D team or more factories that have an R&D team,
yeah,
and plan in some time and start now to be set for starting that or scale that such a program in like 1 or 2 years, right?
Yeah. Yeah, and which are the typical mills which you should select also is an important point. Selection of a mill where you have multiple options and multiple possibilities. Like for example, a garment dyeing, it will be multiple possibilities. So same thing I can achieve, but various processes. Continuous dyeing, same thing is possible. Only yarn dyeing, only exhaust dyeing with only such set of machines, possible, but the effect will be lower. So first, if you want to do a pilot, choose a mill which has options, choose a process where they have multiple options, but they're not getting the best out of them. Yeah, that also is important.
So thanks, Siva. I'm conscious of time, so thank you everybody. If you have more questions, get in touch with myself or Siva. If it's a very technical question, please directly address it to Siva. It was a pleasure for us to have you all here, and thank you so much.
Thank you.